Day 549 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1578, minimum time to make rope colorful. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice has N balloons arranged on a rope. You are given a zero index string colors where colors of I is the color of the ith balloon. Alice wants the rope to be colorful. She does not want two consecutive balloons to be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You are given a zero index integer array needed time where needed time of I is the time in seconds that Bob needs to remove the ith balloon from that rope. Return the minimum time Bob needs to make the rope colorful. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input colors equals the string ABAAC time needed equals an array of integers 1, 2, 3, 4, and 5. The output is 3. Explanation says, in the above image, A is blue, B is red, and C is green. Bob can remove the blue balloons at index 2. This takes 3 seconds. There are no longer two consecutive balloons of the same color. Total time equals 3. So let's go ahead and break this down one step further. So looking at this, we could look at this string, but looking at this picture, right? So each letter in this string represents a different colored balloon. And looking at this picture, we can see we only have to change the color of one balloon, right? Because she doesn't want two consecutive balloons to be the same color, right here. Sorry, y'all. Boom. So, as you can see in this example, there are only two balloons. That only occurs one time where there are two balloons of the same color that are next to each other or consecutive. So that means these are the only two balloons we really need to fix. And really we could fix it by just switching the color of this balloon to green, right? So we only have to worry about changing the color of this balloon to green, and since this balloon is at index 0, 1, 2 in colors, then we're going to come to index 2 and needed time. So index 2 at needed time is 3. So that means it's going to take 3 seconds to change the balloon at index 2, right? Because index 2 is equal to 3 in needed time, and index 2 is where the consecutive color balloons start. Boom. So this is the one we're changing. We're going to change this to green. It's at index 2. Come here, we see index 2 takes 3 seconds, so our total is 3. So just in case that didn't make sense to y'all, let's take a look at example 2. In example 2, we have our input colors equals a string ABC, needed time equals an array of integers 1, 2, 3. Output is 0. Explanation says the rope is already colorful. Bob does not need to remove any balloons from the rope. So as you can see, we have no two balloons that are the same color that are right next to each other or consecutive to each other. So we don't need to change anything. So since we don't need to change anything, the minimum time is 0. So now let's take a look at example 3 where it's a little bit more difficult, but we can still handle it. So in example 3, we have our input colors equals the string AABAA, needed time equals 1, 2, 3, 4, and 1. Output is 2. Explanation says Bob will remove the balloons at indices 0 and 4. Each balloon takes 1 second to remove. There are no longer two consecutive balloons of the same color. Total time is equal to 1 plus 1, which is equal to 2. So let's break this down one step further, right? So in this example, we have two consecutive color balloons here, and we have two consecutive color balloons here. So we want to do the minimum time. So looking at these times, we could change either one of these balloons, right? But if we change this balloon right here, index 1, we come right here to index 1, that's 2. So when we could change this balloon at index 0, and this is takes a time of 1. So since 1 is less than 2, we're going to choose this balloon, or we're going to choose this balloon to change because it's going to take less time. This only takes 1 second, where this balloon will take 2 seconds. Similarly, on this side, we need to do the same thing because there's 2 more consecutive balloons of the same color, so we need to change the color of one of these balloons. Similarly, this balloon right here, index 0, 1, 2, 3. So right here, index 3, come down to 3. This is going to take 4 seconds. It's going to take 4 seconds if we want to change this balloon. But if we change this balloon, it'll only take 1 second. So we want the minimum amount of time. So since we want the minimum, we're going to choose the 1 second balloon over here, and we're going to choose the 1 second balloon over here instead of choosing the 2 second balloon right here or the 4 second balloon right here. We're just going to change this 1 second balloon and this 1 second balloon so that all of these colors, so that this rope can be colorful and there will be no 2 consecutive balloons of the same color. And since they both take 1 second, 1 plus 1 equals 2 because there's 2 balloons we need to change. We need to change this balloon and this balloon. That's 2 balloons. They each take 1 second. 1 plus 1 is equal to 2, so our output is 2. We could change these 2 balloons in 2 seconds, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. So first thing we're going to do is we're going to convert the input string into an array of characters for easier indexing. So to do that, we're going to come right here and we're going to say let R equal an array, open up the parentheses, and we're going to pass in colors just like that. Boom. Then we're going to come underneath that and we're going to create a variable that will store the total minimum cost to remove the balloon. So we need to store our output somewhere. So we're going to declare a variable called res, and we can set that equal to 0 to start. Then we need 2 pointers which will help us traverse the array. So we can declare a variable called L for our left pointer, set that equal to 0. Sorry, y'all. 0. Then we can declare another variable called R and set that equal to 0 as well. Now it's time to iterate through all of the balloons using the left pointer. So we're going to say while L is less than r.count, we're going to open up the brackets. Boom. And we need to track the total removal time for the current group of the same color balloons. So to track the maximum removal time in the current group, we're going to declare a variable called max_t and set that equal to 0. Then the sum of all removal times in the current group we need to track, so we're going to declare another variable called sum and set that equal to 0. Then we're going to expand the right pointer while balloons have the same color as R of L. So we're going to say while R is less than R.count and 2 and signs R square bracket L equals R square bracket R. Sorry, y'all. Come outside of that, we're going to open up the brackets and we're going to add the current balloon's removal time to the total. So we're going to say sum plus equals needed time square bracket R. Boom. Then we're going to come underneath this and we are going to keep track of the most expensive one by saying max T. We're going to set that equal to max, open up the parentheses, max T, comma, needed time square bracket R. Boom. And then we're going to move to the next balloon by coming underneath this and we're going to say R plus equals 1. Boom. Now if there's more than one balloon of the same color in this group, we're going to come underneath this and we're going to say if R minus L is greater than 1, we're going to open up the brackets, and to make all colors unique, we must remove all except the one with the max time. So we add sum minus max T to the total cost minus removing the cheaper ones. So we're going to come right here and we're going to say res plus equals sum minus max T. Boom. Then we're going to move the left pointer to the start of the next group by coming underneath this. We're going to say L equals R. Then we're going to return the minimum total cost to remove balloons such that no 2 adjacent balloons have the same color by coming right here and we're going to say return Reg, y'all. Boom, that should be all she wrote. Let's go ahead and give it a run before we submit it. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Ooh, so look at that, y'all. 16 milliseconds beat 0.0% of users. We could 100% get those numbers up, but I feel like this is a good solution because it's easy to understand and it's easy to learn from. Because if you don't understand the solution, then you probably didn't learn anything. So as we continue down our LeetCode journey, we'll try to get better numbers. But right now, we just want to understand how to solve the problem that is presented to us, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.